Hello guys, welcome back to my channel MNR KRISHNA. Sorry for late updation. Actually, now the semester is ongoing. That's why I'm busy with my examinations. It is very tough to manage both the examinations and the NPTEL course. Finally, I'm uploading the third assignment solutions. I will try to upload future videos also as early as possible. Someone are asking for document. Sure, you can download it from description or comment box. I'll give you. Then thank you for your support. If you are first time visiting my channel, please subscribe my channel and hit the bell icon. Thank you guys. Next, first question, consider the following Verilog code. Okay, the code is given module which is named as XXX. Here inputs are ABC, outputs are D0, D1, D2, D3, and 3 wires are used, which is named as FGH, and 2 NOT gates are used. Sorry, 3 NOT gates are used, and 4 NAND gates in module. Okay, the code represents a positive logic 2x4 decoder without enable, positive logic 2x4 decoder with enable, 2x4 decoder. Okay, by observing the options, we can conclude that the given code is for 2x4 decoder. Here we have to find the code is positive or negative logic, and it is with enable or without enable. For decoder, inputs are only 2, so AB is enough. So let us assume the C is enable. It is clear. It is an with enable 2x4 decoder with enable, which may have positive or negative. For positive logic, here it is the positive logic circuit. We are using 2 NOT gates. Actually, it is without enable. That's why you're using 2 NOT gates only. Okay. For with enable, actually 3 NOT gates are used and 4 AND gates are used. AND gates are used in positive logic. NAND gate means opposite to the other. That means not of AND. NAND means not of AND. So it is a negative logic. For negative logic, 0 is for selection, 1 is not selection. So negative logic 2x4 decoder with enable. Next question, option D is correct answer. Okay, if the code is given in question 1, okay, same code we have to take the same code which is given in question 1. If NAND G4, okay, these 4 lines are replaced by AND, okay, NAND are replaced with AND. Just now we discussed about that. The code represents a positive logic with enable, so option B is correct. Then third question, in the code given in question 1, if the boolean variable C is assigned to logic 1, okay, at the start of the code execution, then always, okay, by observing the options, we can conclude that always D0, D1, D2, D3 are same, and regardless of A and B. Okay, we have to find the value of D0, D1, D2, D3 only. Okay, then for logic, okay, what is that? C is at it. Okay, C is nothing here. C is nothing but enable signal. It is fixed. Enable signal. Question 1 is negative logic 2/4 decoder with enable logic 1. 1 is given to the enable. Okay. Here it is the positive 2/4 decoder with enable by using positive logic. For positive logic, if you enable input as 1, the normal operation is done. For E is equal to 0, all are 0. So that's why for negative logic, if we give E is equal to 0, it will done normal operation. If we give E is equal to 1, we get all are 1. So always 1. So B correct answer. Always D0, D1, D2, D3 are is equals to 1 regardless of A and B. Then which of the following statement is true with respect to the Verilog statement? Buff if 0 yxc. Okay, the buff if 0. Actually, the buffer means it passes the same data. If you give that input as 0, output also 0. If you give input as 1, output also 1. But buff if 0 means buffer with control or buffer with enable. We can control the buffer to get output. Here it is the buff if 0 content. It is the symbol of buff if 0, the logic gate. And here the buff if 0 primitive has two inputs. Those are data and control, and one output. Okay, here Y is the output, X is the input, and C is the control. When the control input is 0, the output passes the same value. So if we apply 0 as enable, that means control. Regarding to the question, here input is X. Here control signal is C, output is Y. So C is equals to in question. What is the C is equals to 0? C is equals to, okay. First we have to apply 0. If C is equals to 0, what is that? C is equals to 0. C is equals to 0. Output passes the same value. So Y is equals to X. So if C is equals to 0, Y is equal to X. A is the correct answer. And then go to the next question. Consider the following Verilog code. Here it is the module XXX YABC. Output is only 1, that is Y. Inputs are A, B, C. Here we are using PQR as wires, and one NOT gate and two AND gate and one OR gate. The code represents a 2/4 decoder, 4/2 encoder, 2/1 multiplexer, 1/2 demultiplexer. By observing that outputs are 1, so I think 2/1 multiplexer. Okay. For the fifth question, directly we can assume that here we are using 1 or 3 inputs. For 3 inputs, there is no 3 inputs. Outputs, C option is only we have 1 output. Let us conclude let us assume C is an enable. then AB are inputs and Y is output. So 2 by 1 multiplexer is correct answer. Even though we have to refer for multiplexer, it is a 2 by 1 mux. Mux means multiplexer. Here using one NOT gate, two AND gates and one OR gate. Okay, that's correct. Next question. In the code given in question 5, okay, the same code is used in this question also. The Boolean variable C is assigned to logic. Here, it is code for 2 by 1 multiplexer with enable. Okay, with control signal. C is assigned to logic 1. So here we applied 1 as C as 1 at the start of the code execution. Then after execution of the code, the value of Y would be, okay, then here it is. Two inputs are I0, I1. Output is only 1. The enable is named as yes. Actually, in question 6th question, 5th coding, Y is the output, A, B are the inputs, C is the control signal. So it is the C is a control signal, A, this is B, this is same as Y. Okay, written on required. For S means C, you have to take S as C. So if we apply 0 to the S, the output is Y0, 1 I1. So see, if C is equals to 1, the output is I1. I1 means B. So sorry, Y is I1. I1 is nothing but B. The correct option is, if C is equals to 1, the output Y is equals to B. My output Y is equals to B. Okay, then consider the following Verilog code module: XXX A B P Q. Outputs are P and Q. Inputs are A and B. Two NAND gates. Okay, then here we using two NAND gates. That to fed back the outputs of one NAND gate to the input to another NAND gate. That means it's a flip flop. It is an flip flop. Okay, for A is equals to B is equals to 0 before the execution of this code. After the execution of code, the values of P and Q would be, okay, for flip flop. Where is that flip flop? Review of flip flops here. Here we, okay, then okay, let us take two NAND gates here only. Two NAND gates. A is output for 1, B is output for K, P, Q. Okay, then one NAND gate and another NAND gate. One is A. Sorry. I think the equation. Let us try. A is equals to 0 in question only. B is equals to 0 and it is P, it is Q. A is equals 0, B is equals 0. For NAND gate, actually the truth table, please wait for 1 minute. Actually the truth table of NAND gate is, if any one of the input is 0, the output will become 1. So if A is equals to 0, it is a input of, it is one of the input of, it is G1, let us take as G1, it is G2. For G1 the output of G2 is 0, so 0 is given as input to the G1. The output will become, this is before execution. After execution B is equals 0, here it is equals to 0. The output of G1 is 1 and A is equals to 0, so 0, output is 1. Then outputs are 0, so sorry, outputs are outputs are 1. So this is example for that. Actually we have to take one terminal. For explanation only I have taken two terminals. If we apply one terminals also, we can same as that by removing this. Here it is circuit, which is get A as input, P is input. Okay, so finally P is equals to 1 1. P is equals to Q is equals to, it is even I am also confusing. For 6th or 7th question I will take up this. P is equals to Q is equals to 1. Here asking, after the execution of code, the values of P and Q would be. So for one time of execution, the P is nothing but 1. Sorry, the A is nothing but 1. A is nothing but 1. So P is equals to 1. Q is equals to 1. B is also 1. P is equals to 1. So that's why I will select this option. In the next question, in the code given in question 7, the same code is using. If A is equals to 0, B is equals to 1 before the execution of this code. After the execution of code, what the values of P and Q would be. Okay, then same. A is equals to 0, B is equals to 1. Okay, where is it? A is equals to 0. Okay, it is the given code. Here before execution is this: a is equals to 0, sorry, a is equals to 0, p is equals to 1. Next, after execution of first execution, p is equals to 1, the output of NAND gate is 0. That means inverse. Here the NAND is used as a not. So here for 0 output is 1. So p is equals to 1, q is equals to 0. After execution, p is equals to 1, q is equals to 0. The option is p is equals to 1, q is equals to 0. Is that true? p1 q0. Okay, p1 q0. That's it, guys. That's it from my end. If you found anything wrong from my video, please comment in comment section. Submit answers. Okay, submitted or not submitted. Assignment not submitted. Okay, I will submit. Assessment submit. Thank you for taking the week 3 assignment. Okay, guys, then for 4th assignment also I will try to upload as early as possible. Please support, guys. Do subscribe and share to your friends. I want much supporters. Here are only 43 subscribers and 322 views, 182 views. Okay, I'm giving you a target for this video. I'm expecting the likes minimum 50 likes. This is very less amount of likes compared to others. Okay, guys, I'm expecting few much of supporting from your end. Out of 322 views, I'm expecting only 50 likes. Based on likes, I will do the next videos. It is very tough to manage, and I'm scared about the timetable also. There is no gap for mid and semester examinations. In the middle of examinations, the NPTEL, this is system design through Verilog examination also. I think that is on 26 September. Okay, my examination is the instructor. Okay, guys, thank you very much. Okay, bye.